An array is a data structure that stores a collection of elements, where each element can be accessed using index or a key. Arrays are used to organize and store data systematically, making it easy to perform various operations on the elements. Here are some key properties and characteristics of arrays. Homogeneous elements. Arrays typically store elements of the same data type. For example, an array of integers will only contain integer values, and an array of strings will only contain string values. Fixed size. In the most programming languages, arrays have fixed size. That means once the array is created, its size cannot be changed. If you need a dynamic size, other data structures like lists or dynamic arrays may be more suitable. Contiguous memory allocation. Array elements are stored in contiguous memory locations. This means that the memory addresses of consecutive elements in the array are adjacent. Zero based indexing. In many programming languages, array indices start from 0. This means that the first element in the array is accessed using index 0, the second element with index 1, and so on. Random access. Arrays support random access, meaning that you can directly access any element in the array using its index. This allows for efficient and constant time access to individual elements. Ordered elements. The order of elements in an array is determined by their indices. This order is maintained throughout the lifetime of array unless explicitly modified. Efficient for iteration. Iterating over the elements of an array is usually more efficient than other data structures, as the elements are stored in contiguous memory locations. Common operations. Arrays support common operations such as inserting, updating, and deleting elements. However, some of these operations may be less efficient than in other data structures, especially if the array needs to be resized. Now let us see the representation of array. The representation of array depends on the programming language. However, I will provide a general explanation of how arrays are represented in memory, using one-dimensional array as an example. In memory, an array is a contiguous block of memory locations, and each element of array is stored at a specific memory address. The memory addresses for the elements are determined based on the data type and the size of each element. Let's consider an example of an array of integers in C. Int my array of size 5, 1, 2, 3, 4, 5. Here my array is an array of 5 integers. In memory, it might be represented like this: element 0, element 1, element 2, element 3, and element 4. In this representation, each element of the array is stored in contiguous block of memory. The size of each element is determined by its data type. Example, int in this case. The elements are accessed using indices. 0 to 4 in this case, as array index starts from 0. The memory addresses of consecutive elements are sequential. In languages like C or C++, you can use pointer arithmetic to navigate through the array elements based on their memory address. In languages like Python, arrays are implemented as lists, and the representation may be more abstract. Python lists are dynamic arrays, and their elements can be of different data types. The internal details of implementation may vary based on the Python interpreter. Understanding the memory representation of array is essential for optimizing algorithms and data access.